Hello, my name is Thomas Dill, a graduate student at Arkansas State University, and today I will be talking about quantifying the extent of cropland flooded for migratory birds in the Arkansas Delta. A little background. The Arkansas Delta once consisted of mainly wetland habitat, but has lost approximately 72% to agricultural land conversion. This has threatened migratory birds looking for resting area, cover, and food throughout their migration. Luckily, winter flooded agricultural fields mimic lost habitat, and as a result, federal agencies and private groups have spent millions of dollars annually in subsidies to promote this practice. However, there is no large scale verification system for winter flooding. We plan on creating a system to both verify and quantify winter flooding in agricultural fields. Looking at the project objective, we have three main goals. The first goal is to compare the predictive accuracy of individual satellite platforms and multispectral indices. The second is to create high-resolution maps of winter-flooded land throughout the Delta. The third goal is to use the maps to quantify any relationship between conservation programs and the flooded areas. Field site selection is the first step we used in avoiding some of the expected complications. The Arkansas Delta has consistent cloud coverage throughout the fall and winter with small windows of clear skies. To increase the chances of viable satellite scenes, a tier system was created. The tiers were created where satellite overlap was greatest. Looking at Figure 1, we can see Tier 1, and this is the area where Sentinel-2 and Landsat scenes overlap. That expands into Tier 2. It's within the red area, and this is where only the Landsat scenes overlap, but you can still get one of the scenes from Sentinel. Tier 3 is expanded out into the rest of the Delta within Arkansas. Next, we look at our methods. To increase accuracy in our data collection, we use global navigation satellite system survey equipment when measuring flood extent. To decrease time at each site and ultimately increase the sites we can visit in a day, we use the Arkansas Department of Transportation base stations with Intrip to remove the need to set up a base station and receive corrections as we survey. To monitor and verify some of the complications we plan on seeing, we are also taking turbidity samples and water depth, all of which occurs on dates that the individual satellites are collecting images of the field sites. We will then compare the indice classification system with the field data using the mean absolute error and the root mean square error. After determining which platforms and indices are the most accurate, Google Earth Engine will be used to quantify flooded fields from 2013 to the present. And Figure 3 shows an example of what we would expect to see, and this was developed using Landsat 8 bands and the normalized difference vegetation index to show the flooding in a couple fields in Poinsett County, Arkansas. Uh, Preliminary data challenges identifying the water. One thing that we expected to see there being an issue with was either turbidity or residue. What we didn't expect was the difference in turbidity between the different crop types. So the first photo is looking above a rice field. The water is 6 inches above the field, and you really can't tell that there's water there, but there's actually 6 inches of water there, and the turbidity is pretty low. Adjacent to that photo is a field, a soybean field, right next to it, where the turbidity is a lot higher, and the water is actually 9 inches deep right there. So there's not a lot more water right there, but the turbidity is so much higher that you can't actually see the ground. And what we've seen is about 190% difference in our soybean fields and our rice fields. This is going to make it a little bit more complicated for us to pick up the soybean fields because the turbidity is so high, it may appear to be more mud than actual water. Another thing is the historical flood area. Um, Again, we used NDVI with Landsat 8, and we used all the points at county, and we ran it. And below in Figure 5, you can see the annual flooded area in each of those, and we'll see dips. And what we hope is that when we use the whole state and we can zoom in on different areas, we can see patterns within the flooding and compare that to what we see with the insertion of different funds from different groups. But I hope this was interesting, and you have a great day.